Hello everyone, my name is Toki Harland Jørgensen and I'm a kernel engineer at Red Hat working primarily on the networking aspects of BPF. And I am here today to talk to you about the promise of eBPF for the edge. So, why am I here and why is Red Hat at the BPF Summit? We're here because Red Hat loves BPF. We invest quite heavily in it in various ways. First of all, we have full support for eBPF on Red Hat Enterprise Linux. We do full kernel backports of all features from newer kernel versions on each minor version of RHEL. So for RHEL 8.7, we are up to upstream kernel 5.14, and for RHEL 9.1, we are up to 5.16. We support kernel features in eBPF, and we offer support for BCC tools and BPF trace. And there's a link to the full documentation and the release notes there. We also have several people working on development of eBPF, myself included, for kernel contributions and in networking, tracing, HID, and others. We also maintain and contribute to various user space libraries, libxdp, Aya for Rust, and we maintain code examples and documentation like the XDP tutorial and the BPF examples repository. All of these are links, by the way, so you can click them if you download the slides afterwards. And finally, we are a platinum member of the eBPF Foundation. So, with all this, and particular with respect to the Enterprise Linux kernel, I would also like to implore everyone to not use the kernel version for detecting eBPF features when you write your BPF programs. Because even though we do full backports of kernel features to RHEL, we don't actually update the kernel version as it is expressed to user space, so you really need to use feature probing to see what is supported. The BPF tool feature output will show you all of this, but you can do similar things in your own application. Now, with all that out of the way, let's talk about the edge. So, what is the edge? It's this thing where operators and application developers discovered the speed of light, which obviously sets us a fundamental limit to how quickly you can respond to applications. If you have your application in a data center in the cloud far away from the user, you do need to incur at least one round trip for every response. And as applications become ever more interactive and latency becomes ever more important, this actually becomes a real limit. So you can do various things to mitigate this, and one of those is moving things closer to the application, so into the edge. And in this respect, the edge here includes, as you can see in this diagram at the bottom, all the various devices close to the user, so mobile devices, Internet of Things, smart things, but also things like CPE devices, the home routers you have in your home. And it also includes the edge infrastructure, i.e. Servers that sit near the edge of the operator networks. So it's sort of similar to a data center, but it's smaller scale, and there's a lot of it distributed around. And obviously, as you move up this diagram, the faster to slower is in terms of response time. So the closer you are to the application, the closer you can respond to user input. And this is, of course, a restructuring where everything used to be really centralized in the cloud. Now things are getting distributed out closer and closer to the edge. And this brings with it lots of challenges. So, what can BPF do for this? Well, in general, BPF works in these different areas: networking, security, and observability. And if you have the intersection of networking and security, you get network security. And the intersection of networking and observability, you get network observability. And security and observability gets you real-time threat detection and response. And if you combine all of them, you can get intelligent sandboxing. So all of these are areas where BPF can be used today, and as we are starting to see applications use them, as you probably know. So moving this to an edge context, what does this mean? Well, for networking, one very important aspect of BPF for networking in an edge context is just simply lowering the overhead, because applications are now running on smaller devices. Some of them are still servers, but they're still smaller servers than what you would see in a data center. And you don't have a whole cluster. You will usually see things like container deployment be on a single node instead of a big cluster. You will also see network function virtualization, NFV, being deployed near the edge. And in general, the applications or the CPUs moving network traffic are smaller and have trouble keeping up. So in particular, XDP acceleration is a type of software offloading where we can keep up with ever higher data rates, even though the CPUs are smaller. So with HTTP, you can do things like accelerate your firewall, your load balancing, or even your packet forwarding, say in a CP on every device, and scale these applications out instead of having big centralized boxes that are expensive and that you can't deploy everywhere at the edge. For monitoring, because applications are distributed out to very small machines, you will need performance monitoring to scale with it and go with it through all the nodes in the network. And here, low overhead performance monitoring is important, which is obviously one of BPF's strengths. Also, it allows you to have always on application monitoring, so you can have usage reporting even though your application scales out over multiple nodes at the end. Finally, for security, things like firewalling and DDoS protection you can no longer do in one place at the perimeter of your data center, now that the application is distributed throughout the edge. You will need to integrate this on every node. And here again, as I mentioned above, accelerating things, for example, with XDP is a way to achieve this. Also application isolation, because you can't provision a physical machine for every application. You really need application isolation to work reliably on a single node, which is also where we see BPF potentially being able to help. And finally, custom security and monitoring and enforcement is an area where you can build in all these capabilities in your application by including a bit of BPF code and getting real-time metrics out of it. Now, all these are areas where BPF can help on the edge, but as BPF gains more ground in these things, there's one issue we really need to solve, and that is eBPF hook coexistence. So as more applications start having more users, coexistence of the different BPF programs becomes important. This means, in particular for the networking hooks, but really every hook you must assume that other programs will access your hooks at some point. Not every hook in the kernel support this natively. In particular, the XDP hook only allows you to load a single XDP program. We've developed libxdp as a way to allow multiple XDP programs to chain on a single hook. And because we see this as a hard requirement going forward, it's actually mandatory to get support on RHEL that you use libxdp for your XDP programs. However, this is not a completely solved problem. More work is definitely needed. We need to define a security model for how different applications can coexist on the same hooks. And we also need better tools for admins to override this. This goes back to the assumption, right? You may think that you can assume that you own the hook and that you will just bail out if another program loads. But as Daniel Borgman was showing us at this year's Linux Plumbers Conference, there's a link to the talk there, this can actually fail because users and administrators may want to run multiple programs and they may step on each other in various ways. So really we need to have some sort of cooperative coexistent hook on most of the BPF hooks. So bear this in mind when you're developing applications. So with this, we think that BPF has a lot of potential for the edge. So how are you going to leverage BPF in your edge solution?